You see an ant? The natural reflex is to crush it. But here's what nobody tells you. That ant already knows your name, not literally, but in every way that actually matters. It does. It knows where you sleep. It knows your kitchen layout. It knows exactly which crack in your wall leads directly to your food. And the terrifying part? It's been studying your house for weeks before you ever saw it. Scientists discovered that a single ant you crush is almost never alone. In fact, the moment you kill it, you trigger a chemical reaction that guarantees more will come. You didn't solve the problem. You announced yourself. Here's something that will genuinely change the way you look at ants forever. When an ant dies, it releases a chemical signal called oleic acid. It's the same compound found in decomposing insects. And to other ants, that smell means one thing. There's something here worth investigating. So every time you crush one, you're basically ringing a dinner bell for the entire colony. But that's only the beginning of how sophisticated these creatures actually are. Because what researchers found when they put ants under high-powered surveillance cameras, that footage became one of the most disorienting things in modern entomology. Ants don't explore randomly. They use a system of pheromone trails so precise that researchers have compared it to GPS routing algorithms. Every path is optimized in real time. Every shortcut, remembered. Every dead end, immediately abandoned. And here's the part that makes you rethink everything. The ant you saw this morning on your counter wasn't lost. It was mapping. That single ant is what scientists call a scout. And its job isn't to find food. Its job is to find you, to understand your patterns, your rhythms, the moments when your kitchen is empty and unguarded. Most people never realize this. They see one ant and think, anomaly, one random bug. But back at the colony, hundreds of thousands of individuals are waiting on that scout's report. Let's talk about the queen for a second, because almost everything you think you know about her is wrong. She doesn't give orders. She doesn't coordinate the workers. She doesn't even know what's happening on the surface of your kitchen floor. She's essentially a biological engine, locked underground, producing up to 2,500 eggs per day. And yet the colony runs perfectly without anyone in charge, which raises a question that genuinely unsettled researchers for decades. Who's actually making the decisions? The answer is nobody. And everybody at the same time. It's called swarm intelligence, and it's so sophisticated that engineers at MIT and Stanford have spent years trying to reverse engineer it to build better AI systems. Think about that for a moment. The thing you almost stepped on this morning is smarter than any algorithm humans have built so far at navigating complex, unpredictable environments. Not smarter in the way you're smart, but smarter in a way that's genuinely harder to replicate. Here's where it gets strange. Because when scientists started studying why ant colonies make such efficient decisions, they discovered something that doesn't quite fit any framework we have for intelligence. Something that made a few researchers genuinely uncomfortable. Individual ants are, by every measure, simple creatures. A brain with roughly 250,000 neurons. No memory beyond a few hours. No awareness of the colony's larger goals. And yet together, without any central coordination, without any leader issuing commands, they build structures that regulate temperature, humidity, and airflow with the same precision as modern HVAC systems. They solve the traveling salesman problem, one of the hardest optimization problems in mathematics, naturally through collective behavior. There's a word for this kind of emergence: superorganism. The colony isn't a group of ants. The colony is the organism. Each ant is more like a cell than an individual, which means when you crush one ant, you haven't killed a creature. You've removed a cell from something much, much larger. And that something is paying attention. Let's go deeper, because the colony's response to threats is where things get genuinely unsettling. Ants have a dedicated caste of soldiers, but the more sophisticated species, like the leafcutter ant or the army ant, have something beyond soldiers. They have strategy. Army ants, for example, don't have permanent nests. They are the nest. The entire colony of up to 700,000 individuals forms a living structure called a bivouac. They interlock their bodies to create walls, corridors, and chambers in real time. No blueprint, no architect, just 700,000 individuals following simple rules that, together, produce something astonishing. When the colony needs to move, it moves as one mass, a river of bodies up to 100 meters wide, consuming everything in its path. Farmers in South America have learned to simply leave when army ants approach, not because of the individual ants, because of what they become together. But here's the part that stuck with me. That collective behavior isn't random aggression. It's calibrated. Scientists found that army ant raids are timed to the colony's hunger cycle, adjusted based on environmental feedback, and modified in real time by signals passing through the swarm. It's not instinct in the way we usually use that word. It's something closer to distributed cognition. And this is where it stops being just fascinating and starts being something you probably want to understand before your next encounter with them. Because the ants in your home aren't army ants. They're not that dramatic. But the same principles apply at a smaller scale. That trail of ants moving across your countertop, it's a live network, disrupted in one place, and the colony reroutes around the disruption within minutes. Kill the ants at the front of the trail, and the chemical signal left by the trail itself becomes stronger, because the reinforcing pheromones pile up without being cleared by passing ants. You made the trail more visible, not less. There's a reason professional exterminators almost never start by killing the visible ants. They understand something most people don't. Here's a detail that most documentaries skip over because it sounds almost too strange to be true. Ants farm, not metaphorically. Actually, farm. Leafcutter ants cultivate a specific species of fungus underground, a fungus that exists nowhere else on Earth. They've been farming it for over 50 million years. They weed it, fertilize it with leaf fragments, protect it from parasites, and harvest it on a schedule. The relationship is so old and so specialized that the fungus can no longer reproduce without the ants, and the ants can no longer survive without the fungus. 50 million years of coevolution, an agricultural civilization that predates humanity by 49.8 million years. And they didn't stop there. Certain species of ants also keep livestock. Aphids, small insects that feed on plant sap, produce a sugar-rich liquid when stimulated. Ants have learned to milk them by stroking their abdomens with their antennae. They protect the aphids from predators. They move them to fresh plants when the current ones are depleted. They even destroy the aphids' wings to prevent them from flying away. Domestication, husbandry, controlled movement of livestock. All of it, without a single written law, without a leader, without a plan that exists in any individual mind. Now, here's the question that all of this leads to. And it's a question that a handful of biologists have started asking quietly, not in mainstream papers, but in side conversations at conferences and in footnotes that most people never read. At what point does collective intelligence become awareness, not consciousness in the human sense, but something, some form of knowing? Because the colony responds to stimuli it has never encountered before. It solves novel problems in real time. It adapts to changes in its environment faster than any individual organism could. When researchers introduced a completely artificial obstacle course into a fire ant colony's territory, one designed to have no logical solution. The colony found a workaround within 40 minutes. No individual ant understood the full problem, but the colony solved it. One researcher described it this way, and I think about this quote more than I should. "The colony doesn't think the way you think, but it is not thinking." Which brings us back to the ant you almost crushed this morning. That ant was a small piece of something that has existed in roughly its current form for over 100 million years. Something that survived the asteroid that killed the dinosaurs. Something that has colonized every continent on Earth except Antarctica. Something that currently accounts for, depending on which study you read, between 15% and 25% of all terrestrial animal biomass on Earth. For every one of you, there are roughly 2.5 million ants. And yet, here's the thing that I find genuinely beautiful about all of this. They don't need to conquer anything. They don't need more territory than they use. They don't produce waste beyond what they recycle. They don't consume resources faster than those resources can regenerate. A civilization that has outlasted almost every other form of complex life on Earth. And it runs on principles that are almost the exact opposite of how human civilization is organized. No hierarchy that matters. No individual accumulation of power. No leader whose death collapses the system. The colony continues. Always. There's one last thing. Something small. Something that changes how this all lands. When you find ants in your home, the instinct is to declare war. Spray, poison, crush, eliminate. But what professional myrmecologists, people who study ants for a living, actually do when ants appear in their space? Most of them redirect. They identify the scout trail, find the entry point, and block it. They remove the food source that attracted the scout in the first place, not because they're sentimental about ants, but because they understand what you now understand. The ants aren't invading, they're prospecting. Give them nothing worth reporting back about, and the colony will cross your home off the map entirely. No chemicals, no casualties, no escalation. Just an understanding of how the system actually works. 100 million years of unbroken survival. Collective intelligence that engineers still haven't fully replicated. A civilization that farms, herds, builds climate-controlled structures, and solves mathematical problems that stump computers. All of it, operating an inch below your floorboards. So the next time you see an ant moving across your kitchen, take 1 second before you reach for the shoe. Not out of mercy, but out of something rarer than that. Curiosity. Because that ant isn't lost. It isn't random. It's a data point in a network that's been refining itself for longer than our species has existed. And the colony it reports back to? It's already decided whether your home is worth the trouble. The only real question is, what did the scout find?